Now I would like to go through the TYS Topic 16 Part 1 selected questions with you. Okay, so the first question that I have selected is this, question 1. A wire of length 1 meter and a resistance 2 ohms. When connected to a cell, the current is 3 ampere. Then a 2 meter length of the same wire is connected to the same cell. What is the resistance of the wire and the current in it? Okay, the answer is twice the length will be equivalent. Remember the resistance of the wire depends on the resistivity, the type of material, length, and cross-sectional area. So as the length increases, the resistance will also increase. So so the question is the current. So basically, if we look at the length has increased by doubled. So the length has increased by doubled. So therefore, the resistance should also be increased by doubled. Okay, so if the length is times 2, my resistance is also doubled by times 2. So if my resistance is 2, 2 times 2 will be 4. So it's either this or this. And however, the current, as the current is 3 ampere. Now, V equals to IR. Well, now when my resistance increases, my current decreases, because when there's more resistance, there will be lesser currents. So how much does it decrease? Decrease by half. Okay, because the resistance doubled, so the current decreases by half. So the answer is 1.5 ampere. So the resistance doubled by 2, the current decreases by 2, divide by 2. So the answer is this. Answer is C. Okay. Right. The next question is question 3. Electric circuit contains a resistor in series with a battery. What are the directions of conventional current and electron flow? Always remember, conventional current is from positive to negative, while the electron flow is from negative to positive. So the answer for 3 is B. Why B? Because this is positive, this is negative. When this is the cell, right? The longer one is positive, the shorter one is negative. Now question 4. A wire has a resistance of 8 ohms. A second wire has half the length but twice the cross-sectional area. What is the resistance of the second wire? Now, there are 2 variables, okay? One is the length and one is the cross-sectional. So length and cross-sectional. So what we're going to do is half the length. So when the length decrease, the resistance also decrease by half. So first of all, we take 8 divided by 2 is 4 ohms. So the length shortened by half, the resistance will become 8 divided by 2 is 4 ohms. But when the cross-sectional area is increased by 2, cross-sectional area increased by twice. So basically, when your area increases, your resistance decreases, because area is the denominator here. The thicker the wire, the lesser the resistance, because easier to flow, right? So you decrease by how much? By twice. So you divide by 2. So 4 divided by 2 is 2 ohms. So answer is B. Okay. Now question 5. current is 10 ampere, switch on for 5 minutes, how much charge? Now what is the formula of charge? Q equals to IT. I is 10 ampere, T, remember it must be in a second, so the answer would be 3000 coulomb D. Alright. Right, another selected TYS question is 9. A wire of length 0.5, cross-sectional 1 has a resistance. Another wire have the same material, that means same resistivity. The length has increased, the cross-sectional has decreased. What is the resistance of the longer wire? Okay, step by step. Room length area. Okay, so when the length of 0.5 increase to 2, okay, so it's actually 0.5 to 2 is 0.5, 1, 1.5, 2, 4 times, right? That means when your length increase 4 times, your resistance will increase 4 times, so times 4. And the cross-sectional area, when it has decreased, alright, it gets lesser 2 times, okay, because 1 and 0.5 is smaller by half, so basically your resistance has increased, okay, when this is smaller, this bigger. When the area, cross-sectional area is smaller, narrower, the more resistant, more difficult for the current to flow through, so it increased by 2. So therefore your resistance will be the original resistance multiplied by 4 times because of the increase of the length 4 times, and multiplied by 2 because of the cross-sectional area decreased by half. Answer would be 6 ohm D. Okay, let's look at another selected question. Section A, question 1. Figure 1.1 shows the circuit of student to investigate how the current varies with across PD, potential difference across state. And this is the results. Suggest what component X might be. Now, what components X might be? Now, this is voltmeter measuring across X. Remember that I over V will give you a straight line. That will give you a fixed resistance, right? So resistance is actually the relationships between I and V is a straight line. Now, but for this case, it's instead of a straight line, it's a curve. So this, it cannot be a fixed resistor, all right? It can only be a variable resistor. Okay, so it allows the it allows the changes of the current when the you will see the changes between I and V when the resistors change. Now, the potential difference across X is 6 volts. Use the graph to calculate the component, the resistance of X as a potential difference of 6 volts. Okay, so the potential difference across the X is 6 volts. 6 volts is here. And what will my current be when my PD is 6 volts? According to the graph, my current will be 0.15 ampere. Calculate the resistance using V equals to IR, R equals to V over I. 6 divided by 0.15. My answer is 40.0 ohms, 3 significant figure. Okay. Part C, calculate how much charge passes through in 1 minute with a potential difference of 6 volts. the formula for charge, Q equals to IT. The current for 6 volts, it was 0.15, right? Remember, 0.15 for 1 minute. Don't forget, it must be in second. The answer will be 9 coulomb. Okay? Alright, don't forget 3 significant figures. Okay, let's come to the last part of the last question for TYS part 1 for the topic 16. Heating elements A and B connected in parallel. Element A has a power 960. Calculate the current. Now, what is we have power. What's the formula of power? Equals to current times voltage. Now, what is the current in element A? It's something that we want to find out, but we know that the power is 960, voltage is 240, and therefore my current is 4 ampere. Okay? Now, calculate the resistance, show your working. Now, we have voltage, we have the current. Now, the voltage here is 240, here will also be 240, and in parallel here will also be 240. Okay, so resistance of elements, so we look at this. V equals to IR. What is the V for element A? 240. What is the I? Is here 4, and what is the R? Is our unknown. Equals to 60. Okay. Now, here, element B has a resistance of 30 ohms. Calculates the combined resistance connected in parallel. Okay, now, what is the resistance here? Now, the resistance here is, if I can draw the diagram again, basically it looks like this. A is, you calculated is 60 ohm. B is stated here 30 ohms. Now, what they want is the effective resistance or the total resistance. When it is in parallel, okay, it should be drawn like that. Okay, if it's parallel, it will be total effective resistor or total resistor. You in parallel, 1 is to 60 plus 1 will 30, and W2 is. Alright, now a lot of students make these mistakes. They forgot to cross multiply. When you cross multiply, it'll be like that. 60 over 3. Answer is. Okay, that's my answer. Simple. Okay, that's the end for this topic part 1. Please complete your answer and correction and submit to your teachers for marking. Thank you so much.